Hello everyone, welcome to our channel Zeal for Python. Let us discuss about how arithmetic operations can be performed on your NumPy array. Operations on NumPy array can be performed in two ways. One is between the two arrays and another is the element by element operation. To perform any NumPy operations, the arrays must be of same shape. And to know the shape of the array, we can use the method shape. Arithmetic operations can be done in two ways. That is, first one is by using the operators, that is plus, minus, multiplication and division signs, and the another one is by using the functions. For example, if we have to add two different arrays by using a particular method, we can use or we can find out that method by using dir method. See here, this dir will tell that numpy, which methods are supported by numpy. Here is the list. And if you have to find out what that particular method does, we can use the help method. For example, if I want to find out what does the function diff does, we use help info and that particular function, which is diff. So now as you can see, you have here that what does this particular function diff does. It calculates the nth discrete difference along the given axis. How to use this particular function is also explained here in the help method. Now if suppose you have a particular array, for example you have this array A1 and you want to check the shape of this array, you're not sure, or you want to recheck the shape of this particular array, you can use the method 3 by 2. This is the shape of the array, means 3 rows and 2 columns. In similar way, for other arrays also you can check. Now all the arithmetic operations can be performed on the array, but there is a condition that both the arrays should be of same shape or same dimensions. If we want to check the dimension of the array, we can use the method ndim. If you want to check the dimension, that what is the dimension of A1, you can use the method ndim. This is 2, means this is the two-dimensional array. Now we can perform the addition of elements of one particular array also. For that we have a method which is called as sum. Now if let us use this array first. So this is our array B. Now if I print it, you will see we have 1 and 12 in one column, 2 and 4 in another column. If you consider this as a square and this row 1 on my left hand side will be my one part of the axis and this 2 and 24 will be on my other part of the axis. So this is my axis 1. Now if I have to do addition on my axis 1, you can see sum is the method to add the elements of one array itself. Sum. Now I will give axis, which is 1. As you can see here, this is my axis. If you overlap this square here, the number which are overlapping are added, and this is the result. If I use axis 0, here 1 and 2 are the first half of my square, and 12 and 24 will be the another half of my square. And you can add this overlapping along the x-axis. The addition is done. I hope it's clear that how element wise addition is done. Similarly, you can add, subtract, multiply, divide, or take out modules of various arrays also. Let us see with the help of example. Suppose I have here array is A1, another array is A2, I will print them. Now as you can see here, I have these two arrays, array 1 and array 2. The dimension of both the arrays is same. To check the dimension, I told you in the part 1 to use the method ndim. So if you want to add both these arrays, simply we can do A1 plus A2 and you can see the result. If you want to use a function add, then add. See, both the methods, addition using the operator and using the method, both will give you the same result. Alright, but this was about when both the arrays have same shape and same dimension. What if both the arrays are different? For that, we have a broadcasting of arrays. When arithmetic operations can be performed only on arrays of same dimensions. But if we want to perform those operations on array of different dimensions, we have to use a broadcasting method. So broadcasting is a mechanism that allows NumPy to perform operations on the array of different shapes. Two rules must be followed for using the broadcasting. The first one is both the arrays must be of same shape. At least shape should be same. Or the next one is the one of them should be of dimension of length 1. When we changes the dimension to 1 of the array, what it does is it stretches the complete array to to match the another array. For example, here we have two arrays. A and B. Now let us see how exactly this works. See, these are my arrays. Now I will print A, print B. See, this is my array A, which has the elements from 0 to 19 and the shape is 5 by 4, that is 5 rows and 4 columns. Another one is my array B, which is only one dimensional array and it has only 3 elements, which is 0, 1, 2, only one row. Now if we try to perform the arithmetic operation on it, it is not possible. So what we can do is we can change the shape or and size of the array. For that, we have a new method which is called as resize. Now if I do b dot resize, now what should be the size of my array? See here, we have here 5 rows. So if I change my array B in 5 rows and only one column, like this, 5 and 1. Sorry. Okay, I resized my array to 5 by 1. Now if I do addition and put it in result, you can see the addition is possible. Alright, but suppose this is also a similar example. Let us try without even having, let us try to add these two arrays without using any broadcasting. So if you can see here, the addition was not proper, not up to date, because only few elements have been added. Otherwise, it's not adding, right? Oh, sorry. See, sorry, because the shape was matching here, that's why only last array was getting added. So if, see, now the nothing is matched here, okay, no column is matching and no shape is also not matching, nor the size. See, what error it is giving? Operands could not be broadcast together with shape 5 by 4 or 3. So this error would have been given here also, in the first also. So in order to avoid that error, what we did is we broadcasted it. Zeros were added to our original array B and the complete array was added to each column of our array A. So this is all about the NumPy in Python. Thank you for your support. Please do like, share and subscribe to our channel. Thank you.